In the chat box, can we have a Gucci in the chat box? Yes, yes, yes. Probably this chapter will be over in the next two classes. Two more classes in this chapter. This was the lengthiest chapter of your O-level IGCSE. I'm not even joking. One of the lengthiest. Then you have organic chemistry, and then you also have states of matter. And see, there's one more rule in the classroom. One more rule in the classroom, everybody. If you are sitting in the live class, just one rule. If you're sitting in the live class, make sure to have taken all the previous classes, you know, all the if you've missed them, go home, take recordings, and then sit in the live class. This is very important. This has been my rule number one since day one, right? Because it's a story, and all of you guys who've been taking the classes since day one, they're still available on YouTube. It'll also be available on your portals, but if you don't have access to the portal yet because it isn't made, you can go on to Carboxyl Chem on YouTube, and you guys can watch the prior recordings, because it's a story. You won't be able to understand it if you've not taken the previous classes. Done, everybody? That's the only rule I have, nothing else. Chali, let me also give you guys a quick recap, Reno. Sir, question before we start: when will we get access to the portal? Hopefully by this week, inshallah. You'll get the recordings are available on YouTube for now, Arush. They are all available on YouTube. You'll get access to the recordings by the end of this week. Okay? Okay, great. Hopefully you'll all get access to it. I'll also start uploading there. Okay. So we started off with the lengthiest chapter, one of the lengthiest chapters, states of matter. We realized that, matter is made up of mass, it has volume, and there are different states of matter: solid, liquid, and gases. And we also understood two things about it. We understood that it has certain properties through observations, and then we understood the reason for that. What was the reason for that? It was the KPT, the kinetic particle theory. And we discussed in the kinetic particle theory that the reason why something is a solid, the reason why something is a liquid, the reason why something is a gas is because the teeny tiny particles which make it up has a certain motion, has a certain arrangement, and also has a certain particle separation that causes that matter to be a solid, which causes that matter to be a liquid, which causes the matter to be gas. And we discussed the motion, the particle separation, and the arrangement for all three: solids, liquids, and gases, right? And then we further discussed the reason for the motion, arrangement, and particle separation. See, it's a three-step process. First, we observed a solid. We realized it had a fixed shape, a fixed volume. If we looked at a liquid, it took the shape of the container. It did not have a fixed shape, but it had a fixed volume, and it had it was almost incompressible. Solids, they are incompressible. Liquids were almost incompressible. Because why? And gases were compressible. The reason was that there were large spaces. For gases, the reason why they were compressible was because there were large spaces between the gas particles, and there were no large spaces between the solid and the liquid particles. Hence, they were incompressible or almost incompressible. And then solids had the highest density, gases had the lowest density, and liquids had density higher than gases and lower than solids. And the reason for these observations were the kinetic particle theory. We looked at the kinetic particle theory and we said, hey, the reason why solid is showing these properties, the reason why liquid is showing these properties, the reason why gases are showing these properties are because of three further factors. And those three further factors were the motion, the arrangement, and the particle separation. Solids, they vibrated about a fixed position. They had a lattice. Lattice means what? Irregular arrangement. It's just a fancy way of saying regular arrangement, right? So it's a lattice of particles. And then particle separation for solids is how far or how close the particles are to each other. And we realized that for solids, the particles are quite close. They are close together, or you could say they are tightly packed or closely packed and whatnot. And we looked at liquids as well as gases. And then for all of these, for the observations, for the kinetic particle theory, the motion, the arrangement, the particle separation, we realized what was causing this motion, what was causing this arrangement in solids, what was causing that arrangement in particle separation. That, my dear fellas, that was a gluing force. and you're not going to write gluing force in your exams. You're going to call it the scientific word, which is intermolecular forces of attraction, right? So gases, they have liquids, they have solids, they have all of these particles have a gluing force called the intermolecular forces of attraction, which is strongest in, it is strongest in what? It is strongest in solids, it is weakest in gases, and then in liquids it's stronger than gases but weaker than solids, right? And we realized that that was in fact the reason why solids were showing you a motion where they vibrated about a fixed position, because they had the strongest intermolecular force of attraction. They had little to no space to move, so they would just vibrate. The reason why they had a regular structure was because they were tightly packed, they were closely packed. And why were they tightly and closely packed, which resulted in this structure? Again, the intermolecular forces of attraction. Makes sense? And gases, they were far and apart, so that is the reason. The intermolecular forces are the reason why they were far and apart. That was the particle separation. The motion was, it has a random motion at high speeds. The arrangement was, it had a random arrangement, because the intermolecular or the gluing force was actually the weakest. And that's the reason, because the gluing force was the weakest, that's the reason gases had the highest energy. So if you look at the energy of gases, liquids and solids, liquid and gases, the energy actually increases when you go from a solid to a liquid and then from a liquid to a gas. That is what we've done up until this point, right? This is, I've just summarized it. Remember, see, I always give you guys a summary of the previous classes, but the summary keeps on getting shorter and shorter and shorter to cover everything, right? So this is what we had discussed, and what was actually a practical observation of the intermolecular forces of attraction. I actually showed it to you guys. I was like, hey, Sir Suleiman had 3 phases. In one phase, he was very tiny, he was very little, and he wanted to, you know, go into the wall and then disappear into a portal like Harry Potter and whatnot. And when I ran towards the wall, I bumped into it, I collided with the wall, and I hit my head and fall back down. And I started crying. I was like, wah, Mom, why couldn't I pass the wall like Harry Potter? My mom's like, because Harry Potter is what? It's not a real story, right? The reason why I couldn't go through a wall was because the wall particles were tightly packed. And why were the wall's particles tightly packed? It's a solid. Why were the wall particles tightly packed? Because it had the strongest intermolecular forces of attraction. Yeah. And then when I started swimming, I realized that I could actually swim in water. Why was I able to swim in water? I was able to push the particles, the water particles behind me. And the reason was that the intermolecular forces of attraction were not that strong. That's why I was able to move through water. And then when I moved in, day-to-day life on a road, when I was moving in air, I realized that, hey, I can move even freely in air. Why? Because it has the weakest intermolecular forces of attraction. That's why air particles, are far apart and all the reasons. Yes, Saf. Yes, kiddo, you could use the mic. Jaldi. Ji. Sorry? Gluing force is the intermolecular forces of attraction. Okay? Welcome. Khair, acha, aage badhte hain. Now, yesterday we ended the class by saying that scientists also wanted to go from one state to another, like going from a solid to a liquid and a liquid to a gas. And that is what they called changes of state. What is state? Forms, right? So you're changing forms. You're going from a solid to a liquid to a gas. And the question was, the big fat question was, how to do it? How do you go from a solid to a liquid and to a gas finally, and then from a gas to a liquid and then to a solid? Now, you all might have rote learned these things, but let me just visualize it for you guys and let me open your brains a little bit, right? Now, when scientists started thinking, they wanted to move from one state to another, because they knew that, certain particles, certain matter can exist in all these 3 states. I'll give you the basic example. H2O. H2O solid is called ice. H2O liquid is called water. H2O gas is called what? It's called steam. right? So we knew that the same matter could actually exist. In fact, it could actually exist in three states. It could either exist in solid, it could exist in liquid, it could also exist in gas. The question was, how do you go, how do humans go from solid to a liquid and then liquid to a gas and vice versa? That was a very beautiful question that scientists started to ask each other. Nobody had the exact, way forward to actually change the state. But then came your awesome teacher, Sir Suleiman. And Sir Suleiman said, hold up a second, you guys are all smarty pants, but let's just go to the root cause. And everybody was like, what do you mean, root cause? I was like, let's look at the root difference between the three. And people are like, oh, one is solid, one is liquid, one is gas, right? But I was like, why is something solid? Why is something liquid? Why is something gas? Then students said, and all the mini scientists said, it's because of the KPT. It's because of the kinetic particle theory. These three reasons. And then I was like, why are these three reasons different for solid, liquids, and gases? And they finally came to the one and only reason for all of these things, which is intermolecular forces of attraction. And then I actually showed students that, hey, now you've reached the root difference. The root difference between solid, liquids, and gases is the intermolecular forces of attraction. And students just said, what do you mean by this? And I said, wait, I'll show it to you. So I went up, I searched a diagram for solid, liquids, and gases, and I showed it to students, just like I've been showing you these diagrams throughout these classes, right? I said, look at a solid. Look at the solid. A solid particle, the reason why something is a solid is the final reason ends up with intermolecular forces of attraction. Solids have the strongest intermolecular forces of attraction, and gases have the weakest intermolecular forces of attraction. And then for liquids, we know liquids have stronger intermolecular forces than gases, but weaker than solids, right? Weaker intermolecular force of attraction than solids and stronger than gases. So I was telling all these mini scientists, I was like, scientists, hold up. What if I start to weaken the intermolecular forces of attraction? What if I start to overcome the intermolecular forces of attraction that holds a solid particle in place? What if I start to overcome these intermolecular forces of attraction? And one of you said, Eureka, sir, then you're going to go into a liquid. And then I said, hey, what if I start to overcome the intermolecular forces of attraction between liquids? What am I going to end up with, everybody? If I start to overcome the intermolecular forces of attraction between liquids, I am gonna end up with gases, right? So if I take the strongest intermolecular force of attraction, I start to weaken it up, I start to overcome it, I'll end up with a liquid. And if I start to overcome the intermolecular forces of attraction of liquid, I will make it even weaker, aka being the weakest, I'm gonna end up with gases. That's the root difference between these three states, right? And then somebody asked, sir, how am I gonna do it? I said, it's pretty easy. Heat it up. Heat it. And then we started looking at the science behind it. So now let's come to the science. We now know the root cause is, how do you go from a solid to a liquid? Somehow you need to start to overcome the IMF, and then you're going to go into a liquid. And then once you start to overcome the IMF of liquid, you're going to go into a gas. The question is, how do you do that? Heat it. Heat it, literally. Now what happens when you heat a solid? Let's take the example of ice. I want to convert ice into water. Now ice is a solid and water is a liquid. I start to heat the ice block up. Now when I start to heat the ice block, I realize that there's an increase in temperature. Obviously, when you heat things up, the temperature of the ice particles is gonna start to increase, right? Because you're heating it up, the energy from the heat source is gonna be transferred to these particles. Ryan, just give me a second. The energy from this heat source is gonna transfer to these particles, and the temperature of the ice block is gonna start to rise. And when the temperature starts to rise, you'll also realize that the kinetic energy of particles also starts to increase. What is kinetic energy, anybody? Kinetic energy क्या होती है? It's actually the energy due to motion. This is a physics teacher's job. Yeah, this is a physics teacher's job to explain to you guys what kinetic energy is. For me, kinetic energy is just energy due to motion, right? It's like when you move from point A to point B, you're converting your chemical energy that you've eaten, the food that you've eaten, that's being converted into motion energy, which you call kinetic energy, right? So when the temperature starts to increase, obviously the kinetic energy is going to start to increase. What I mean by that is that the particles will start to vibrate faster and faster and faster and faster. Why? Because now they have more energy. So can I say, when I heat an ice block up, the temperature increases, due to which the kinetic energy of particles increases. And if the kinetic energy of particles increases, I'm going to realize that, hey, the particles start to vibrate faster and faster. Particles start to vibrate faster and faster. Why? If you've studied this in your physics, I'll also give you the physics explanation to it. In physics, you know that kinetic energy is half mv square, right? So if kinetic energy is increasing, obviously the speed, the velocity or the speed is obviously also going to increase, which means that the particles will now vibrate faster and faster. That's why I said that when you heat a solid up, the temperature is going to start to increase. Due to it, the kinetic energy will start to increase, and because the kinetic energy is increasing, you'll realize that the speed of the particles is going to increase. And what's the speed? The vibration motion, right? So the particle will start to vibrate faster and faster, quicker and quicker, faster and faster, and they will start to vibrate so fast that eventually they will overcome the intermolecular forces of attraction that holds a solid in place, or that holds the ice particles or the solid particles in place. And what happens? Voila, you end up with a liquid. The particles are now slightly separated because you've overcome that force, right? So what I've done is, what do I do? I start to heat it. When I heat it, there's an increase in temperature, and because there's an increase in temperature, there's also an increase in the kinetic energy, which means that the particles start to vibrate faster and faster and faster and faster and faster and faster, and they will vibrate so fast that eventually they'll move further apart. And when they move further apart, they're gonna overcome the intermolecular forces of attraction that holds the solid in place, and you're gonna get a structure that looks like a liquid. In fact, you're gonna get a liquid, right? So I'm gonna say eventually they move further apart, thus overcoming the intermolecular forces of attraction. Yeah, let me fix the English. Thus overcoming the intermolecular force of attraction that holds the solid particles in place. Make sense? Easy peasy lemon squeezy. And then I ended up with water, and you're going to get all the properties of water. The particles are now slightly separated. The motion is that they slide over and past each other, or they slide over each other, and the arrangement is that now they are randomly arranged, or they have an irregular arrangement, right? But now I take the same liquid, I take the same water, and what do? I want to go into a gas. So if I take the same water and I want to go into gas, what am I going to do? I'll further heat this up. So when I further start to heat it, I realize that this liquid, it's gonna start to, I heat it up, the temperature of the liquid is gonna start to increase, and if the temperature increases, remember the kinetic energy always of these liquid particles will also increase. And if the kinetic energy is increasing, kinetic energy is what? Half mv square. So if the kinetic energy is increasing, the speed of the particles is gonna increase, which means that the particles move faster and faster. Eventually, what will happen? Eventually, moving further apart. And if they move further apart, that means that they have completely overcoming the IMF that holds the liquid in place. The intermolecular forces of attraction that holds the liquid in place. And the particles will escape into the air. Sorry for my pathetic writing, guys. I'm just quickly writing it because you've gotten the idea. The idea is pretty simple. You have to play with the intermolecular force of attraction. What's the difference between the first points and the second point? What's the only difference between solid to a liquid and then liquid to a gas? There's one difference, tiny difference. I hope you see, but two differences. Can somebody identify those two differences? Yes. I'm saying what are the two differences between these two processes? I'm doing the exact same, but what I'm doing the exact same thing. But what's the scientific differences between these two? What's the differences in reasoning between these two? Somebody's DMing. Yeah, no, we're not talking about physical changes for now. Yes, Hawa is right. Absolutely right. Hawa, 10 rupees naam, please message me your Easy Pass account. Please. I'm not even joking. So, see, in one case, you are completely overcoming the intermolecular forces of attraction. Here, you are overcoming the intermolecular forces of attraction, but it's not that much. You know, for gases, you have to completely overcome it because realize that gases have the weakest intermolecular forces of attraction. It's like near negligible. That's why we use the word completely. And there's also one more difference, which is a little bariksa difference that you guys have to identify. See, do you want me to tell it to you or can you guys identify it on your own? Yes? No, they're all moving further apart. You're close, you're close. No, 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 no. You guys are close, but no, 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 no. See, the second difference is that when I talked about the solid and I said that the particles start to increase, the kinetic energy of the particles start to increase, I used the word vibrate. I did not use the word move because solid particles don't move. That's the biggest mistake that students do. They say you heat it, the temperature increases, kinetic particles increase, kinetic energy of particles increases, and the particles start to move faster and faster. The examiner puts across there and then. Why? Because solid particles can't move. They vibrate. They only start to move once they've overcome the intermolecular force of attraction that holds the solid in place and they become a liquid. Only then do they start to move. And here, see, I've written the particles move faster and faster. So movement is for liquids, not for solids. They vibrate for solids. Yes, 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 yes. Bole. Sure. Yeah, you could think about it like that. You could think about it like that. Yes, sure. Why not? ठीक है? Chalo. That's how you go from a solid to a liquid and then from a liquid to a gas. Right, everybody? And then students, and then my students, they said, sir, what about going from a gaseous state to a liquid state? How can we do that? How can we go from a gaseous state to a liquid state? I said again, think about the root difference between gases and liquids. What's the root difference between the two? Can anybody tell me the difference between gases and liquids? No, no, it's not that. The root difference. Anji, Anji, Anji. I literally discussed it in so much detail. The difference. Yes, how you can speak too. Yeah, sure. No. Yes, Hava, sorry. No, 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 I literally discussed the root difference when I started explaining to students. Yes, the intermolecular forces. Yes. See, that's the difference. What are we trying to do? How are we changing states? We're actually playing with the IMF. I've written it here. That's the core difference between these three. So, by going from solid to liquid, what was I doing? I was playing with the IMF. I wanted to overcome the IMF, and that is the reason why I did what I did. I heated it because once I heated it, the temperature increased, the kinetic energy of particles increased, they vibrated faster and faster. Eventually, they move further apart, and therefore, you had the intermolecular force of attraction were weakened, or you had overcome the intermolecular force of attraction that held the solid in place and ended up with a liquid. And the same thing I did with liquid because I'm playing with IMF. I have to overcome the IMF in order to go from solid to liquid and then to a gas because I know that solids have the strongest IMF and gases have the weakest IMF. But what if I want to go from gases to liquids? Then what am I supposed to do? See, I'm going to look at the IMF. Gases have the weakest IMF and liquids, they have stronger IMF than gases. So how can I go from a gaseous state to a liquid state? I have to actually strengthen the intermolecular forces of attraction. I have to strengthen the intermolecular forces of attraction. And for that, you need to understand that if I were to weaken it, I was heating it up to weaken it, right? And we understood the science behind it. I was heating it up to weaken it. What am I going to do to make it stronger? I will cool it. Yes, thank you, Saf. So I started to cool the gas particles, and when I started to cool the gas, it's literally the ditto opposite. So I started to cool it, and then what happens when I cool the gas particles? There's going to be a decrease in temperature, which results in a decrease in kinetic energy of particles. Please, you have to write these terms. Whatever I'm writing, this is your 3-mark answer. So there's a decrease in temperature, due to which there's also a decrease in kinetic energy of particles. And if there's a decrease in kinetic energy of particles, this means that mv square, v is going to decrease, the speed is going to decrease. And when speed of particles decrease, do they move further or do they come closer together? See, gas is in east west. When somebody farts, goes for east west, da da da. But if I start to cool the fart down, what's going to happen? The particles are going to come closer together. Why? Because now they don't have that much energy. You've taken away that energy. There's a decrease in temperature, which decreases the kinetic energy. So what happens when you decrease the kinetic energy? The speed decreases. So particles move slower. Particles move slower. And when they move slower, what happens? Do they move further apart or do they move closer to each other? Farther apart or closer? Obviously, they then move closer together, and when they move closer together, we say thus strengthening the intermolecular forces of attraction, strengthening the IMF, the intermolecular force of attraction, and forming a liquid, not a solid. We went from a gas to a liquid. Easy? Kitna aasan? It's literally the opposite. You need to write these terminologies. You need to say cool the particles. When you cool it, there's going to be a decrease in temperature, which decreases the kinetic energy of particles. Particles move slower and therefore closer together, thus strengthening the intermolecular forces of attraction and forming a liquid. Easy? Similarly, when we looked at, in contrast, when we looked at solid to liquid or a liquid to a gas, when we discussed liquid to a gas, what did we do? We did the exact opposite. We heated it up. There was an increase in temperature, which increased the kinetic energy of particles. Particles move faster and further apart, therefore completely overcoming the IMF. Easy? कितना आसान है यार, हलवा है और ये बच्चों वाली चीजें हैं. Arush, I'm going to answer your question in a while. Just hold up a moment. And then I said, no sir, what if I want to go from liquid to a solid? What do I have to do? What is the core difference between the two? The core difference between a liquid and a solid. Yes, thank you very much, Saf. So it's the intermolecular force of attraction. Solids, they have the strongest intermolecular force of attraction, and liquids have weaker IMF compared to solids. I'm comparing it to solids. Now, what do I have to do in order to go from weaker to stronger? In order to go from weaker to stronger. Weaker to stronger. Yes. Okay. So what am I going to do? I will cool it. And what happens when you cool it? There's going to be a decrease in temperature, which decreases the kinetic energy of particles. Particles move slower. Because why do they move slower? Kinetic energy is half mv square. So the speed decreases. Particles move slower and closer together. Yes, sir. And once they move slower and closer together, thus strengthening the IMF, intermolecular forces of attraction, and forming a, sorry for my gandhi writing, and forming a solid. Easy peasy lemon squeezy, everybody. Asan ki mushkil? Yes, Zainab. Yeah. Hold up, Zainab. Hold up. We'll go into that in a while. Right? Acha. No. We'll look into that hopefully in the next class. Okay. Aram se. Everybody is so curious to learn. First of all, let me tell you guys a couple of facts about these processes that we've done. The process of converting a solid to a liquid, this process right here, that's called melting. Yeah. What is melting? It's the process. I know it's the most boring chapter, but what can I do? I have to teach everything. So it's the process of converting a solid to a liquid. True? Yes, everybody? Yes? Okay, my question to you guys is, what is meant by melting point? What's the difference between the two? Melting point is also the process? No? Okay, everybody's speaking. Everybody's speaking together. Hold up. Let's give Aiza the chance to speak. Yes, Aiza, you were saying. Was Aiza talking? Yes. Jaldi. Achha, Aiza is not talking. I thought Aiza was talking. Who was talking? I think Alina was talking. Some A or Ibrahim. Chalo. Always raise your hand when I ask the question. Right? That's right. Ibrahim, you can speak. Yes. Go for it. Okay. Not exactly, but okay. I like the yes, Halima. No. That's the biggest mistake that all students makes. It's the temperature. No, it's not just the temperature. Remember, guys, it's the yes, Ramin. No, that's the process. When a solid turns into a liquid, that's called the process. That's melting. Melting point is the constant temperature at which solid changes to a liquid. And for water, it is 0 degrees Celsius. It's the constant temperature at which a solid changes its state into a liquid. Why is the temperature constant? That should be the next question that we'll look into tomorrow. For now, I want to quickly go over these processes, right? Now, liquid to gas. Liquid to gas. What is this process called of converting a liquid to a gas? No, not quite. No, this process right here. This process. No, this process is called boiling. When you boil water, what do? You convert it from a liquid state to a gas. Tabah hai ye kaum madhak kar raha hu. I'm joking. You're all here to learn. I love the enthusiasm. Love it. So it's called boiling. There's a difference between evaporation and boiling. We'll look into that later. But this process right here is called boiling. Right now, what is this process? Boiling is what is the process called? It's the process of converting. It's the process of converting a liquid to a gas. If you guys get confused ever, you could just think, what do you do with water? You boil it. What do you mean boiling water? What do you mean boiling water? You're literally converting it from a liquid to a gas, right? So this process is called, the process of converting a liquid to a gas is called boiling. But what do we mean by boiling point? What is meant by boiling point, anybody? Point, remember, it's the constant. Yes, remember. Yes, it's the constant temperature at which a liquid changes its state into a gas. And for water, for H2O, it's actually 100 degrees Celsius. For pure H2O, it's 100 degrees Celsius. Just give me a moment, Saf. Then, so we've discussed these two, right? Then, what is this process called? The process of converting a gas into a liquid. What is this process called, everybody? That's called condensation. But what if I ask you guys what is meant by, I'll write it here, condensation. What if I ask you guys what is meant by condensation point? Yes, thank you very much. The constant temperature at which a gas changes its state into a liquid. Now, always ask the question why. Your questions are all valid. Why is it a constant temperature? You learn that tomorrow. It's a little complicated. We'll learn that tomorrow. But for now, I just want you guys to get a hang of the differences between what a process is and what the constant temperature is. This is what students even get confused with in A2 level physics. In A2 level physics, they get these questions wrong. I'm not even joking with you guys. So in A2 physics, there are questions about what is the differences between between condensation or condensation point or boiling point, they get it wrong. Why? Because their O-level basics aren't good. That's why I spend the most time on this chapter. Last, Saif, just a moment, please. Just one moment. Acha, last, liquid to solid. What is this process called? The process of converting a liquid to a solid. एक love सबने that's called freezing. Yes, thank you very much. So the process is called freezing, right? What do you do in a freezer? Think about it logically. Don't rote learn things. Think about it logically. What do you do in a freezer? You take water and you place it in the ice cubes and you put it into a freezer. And what happens to water? It goes from liquid to a solid. Literally. Acha, one more thing, guys. What's the condensation point for water? The condensation point for water is also 100 degrees Celsius. It's the same as boiling point. क्यों? कल पढ़ेंगे. Acha, freezing is the process of converting a liquid to a solid. And then my question to you guys is, what is then meant by freezing point? Yes, it's the constant temp where the liquid, or at which the liquid changes its state into a solid, right? The only difference is one is a process and one is a constant temperature. Why is it a constant temperature? That's a story for another day. But my question to you guys is, what's the freezing point for water? It's literally the same as its melting point. It's 0 degree Celsius, right? So for now, we've realized that the melting point and the freezing point are the exact same. Both are 0 degree Celsius for water, please. For all substances, they are different. For water, you need to know it. That's why I'm using the water as an example, right? And then the condensation point, or the boiling point, and the condensation point is the same for water. It's 100 degrees. Sir, why do we use different names for it? Why do you use? Because it's just the difference between whether you're cooling it or you're heating it. You call it the melting point or the boiling point when you're heating it up, and you call it the condensation point or the freezing point when you're cooling it down. That's the only difference. The temperatures are the same. Why are the temperatures constant? We'll talk about that tomorrow, inshallah. But just two more things. And two more things. Guys, always remember a couple of, I want you guys to think from all perspectives, right? Dekhiye, when solids start to melt, now my question to you guys is, what will happen to the density? What will happen to the density? It will decrease. So such questions can be asked by the examiner. It hasn't been asked before, but it can be asked by the examiner because it's moving towards a more conceptual approach. Because see, realize, when you go from a solid to a liquid, now it's going to have all the properties of liquid. So you went from highest density in solid to slightly lower density in liquid. And the reason for that is, it'll have the same mass. You know, if it was 10 gram solid, it'll be 10 gram liquid as well. In this case, it'll have the same mass. But once it becomes the liquid, the particles are not too tightly packed now. The particles are close together but slightly separated. And if the particles are slightly separated, that means that the volume increases. And what is density? It is mass over volume. So the mass is the same, that's 10 gram. But for liquids, the volume increased actually. That is the reason why when most solids melt, their volume increases slightly. The mass is the same, but volume increases slightly, due to which the density decreases. Because what is happening? You're increasing the denominator. Let's suppose first the denominator was 5, now the denominator is 7, because the volume increased slightly. Why did the volume slightly increase? Because the particles are now slightly separated. Why are the particles slightly? See, you should know every why. Why are the particles slightly separated? Because now you've overcome the intermolecular forces of attraction that holds the solid in place. Makes sense? So if I asked you, why are liquids less dense than solids? Why? Such questions have never been asked, but you know, I reckon they can be asked. Why are liquids less dense than solids? No, it has nothing to do with force of attraction. Yes, Alina, Arush, kaun bol raha tha? Please always raise your hand, kiddos, so I can give you guys an opportunity to speak. Because I want everybody to participate. Yes, Aisha. Yes, because of the weaker IMF. What happens because of the weaker IMF? Complete statement. What happens because of the weaker IMF? The particles are, try to connect them. It's okay. The particles are slightly separated. The mass is the same, but the particles are slightly separated. Right? That's true. And if you could see it even here, Aisha, look at this. You could literally see it. The particles are now slightly separated, and if they are slightly separated, that means they will take up more space. More space means more volume. So the particles are slightly separated, thus having a higher volume, and therefore what happens to the density? The density decreases because the mass is the same. ये भी 10 ग्राम है और ये भी 10 ग्राम है. That makes sense, everybody. Mass can neither be created nor destroyed. Make sense? Easy peasy lemon squeezy. Easy peasy. Such question has not been asked before. Yes. Acha, one more thing, everybody. One more thing. एक और बात. 2 सेकंड रुकिएगा जरा. Last question. One more question. क्या पूछ रहा था? What was I gonna ask you guys? It was a very good question that came to my mind, which the examiner has not tested before. But hey, I forgot. Maybe I remember tomorrow. Yes. What if I ask you, what happens to the energy when you convert the energy of particles, when you convert a solid to a liquid and then liquid to a gas? What happens to the energy when you're converting? It increases. It increases. Yes, everybody's right. Awesome. What happens to the energy when you go from, because you realize that energy in gases have the highest energy. Solids have the lowest energy, right? So if I ask you what happens when you go from gas to liquid to solid, what happens to the energy? It decreases. And somebody asked me last time, sir, when you say that the intermolecular forces are the strongest, you said that energy is the lowest, right, for solids. This is actually the real reasoning. The reason why gases have the highest energy, now you'll be able to understand it. लेकिन कुछ चीज़ जहाँ हम बस ऐसी examples दे के जान छुड़ा देते हैं, but now you'll be able to understand. See, let's suppose these solid particles had 10 joules of energy. Joule is the unit of energy. I'm just making you guys visualize things. Let's suppose this had 10 joules of energy. What did you guys do? What did you guys do initially? What did you guys do? You guys started to heat it up, didn't you? When you wanted to convert this solid into a liquid, what did you do? You started to heat it up. And when you started to heat it up, I said that the kinetic energy increased because this heat energy is now gonna be taken in by these particles, right? So it's gonna go from 10 joules to maybe what? To maybe, let's suppose, 15 joules. And that's why liquids have more energy than solids. Yeah, makes sense? And then you start to further heat the liquid. So what happens? 15 joules plus the heat that you're giving it. That is the reason why, let's suppose this is 30 joules. That's the reason why gases have the highest energy. Will the examiner ask you this question? No. You could just say the reason why gases have the highest energy is because it has the weakest intermolecular force of attraction. But that's the real reason. किसने ये सवाल पूछा था कल? Energy का. Make sense to you now? जिसने भी कल पूछा था मेरे जहन में एकदम से आ गया तो मैंने कहा चलो बता देता हूँ. So this is what happens. This was the energy. You gave it more energy. It took in energy. Boom. More energy. More energy. So that's why gases have the highest energy. Liquids have lower than gases. And solids have the energy lowest. But it has the strongest IMF. Make sense, everybody? Please, when the examiner asks you changes of state, these are the exact points you need to replicate. These are the exact points you need to replicate. Abne se filhal टर्नेली नहीं मारिएगा. Thank you. Okay, last. बस एक और चीज. बस last concept. कल कर लें कि आज बस आखिरी. There's also something known as sublimation. Do you know what sublimation is? Awesome. Yes, Aisha. So sublimation is also a process, and you need to know this process. Sublimation is the process of converting a solid into a gas, but not just into a gas, solid directly into a gas. So if you want me to write the English for it, you guys are too little, I'll write it for you. Process of converting a solid directly into a gas without being converted into a liquid. It doesn't even come to the liquid state. It doesn't even come to the liquid phase. It just goes solid and boom, goes into a gas. And what is resublimation? Desublimation, not desublimation. Yes. So it's literally the reverse of this. Desublimation is when a gas, it's literally the reverse of this. When a gas converts directly into a solid it's a process of converting a gas to a solid without, you need to write this, without being converted into a liquid. Please, you need to write this. And I'll give you a couple of examples for it. You could think about iodine Have you seen iodine? Iodine is a gray-black solid. And I'll also send you guys a video because it's going to take me time to find it. Maybe I show it tomorrow in the class. But it's a gray-black solid. And if you heat iodine up, it directly goes into iodine vapor, which is purple vapor. So we say it's sublimed. What is sublimation? It is when a solid changes its state directly into a gas without being converted into a liquid. And the same thing, if I take iodine gas and I start to convert it into a solid, I start to cool it, it goes directly into a solid without being converted into a liquid, right? That's what happens. And there are more examples like carbon dioxide solid. Dry ice, you call carbon dioxide solid as dry ice. It literally goes from carbon dioxide solid to carbon dioxide gas. Literally, it sublimes. Why do we use the word sublime? We use the word sublime because it does not even enter the liquid phase. It goes directly into a gaseous state without being first converted into a liquid. That's the last process. Tomorrow we are going to understand why are the temperature constant temperatures, right? And one more fun fact. Aisha, I'll take your question. Just one more fun fact, guys. That some of you, chalo, Aisha, I'll first take your question, then I'll answer, then I'll move on with the extra. Why? Then I'll take all your questions. Why? Why does this happen? Hold up, it's just the reverse of sublimation. Why does this happen? Not in your course. But you want me to tell you the why? It's pretty easy. You guys can easily figure it out even on your own. Why? Intermolecular force of attraction. See, why would something go directly from solid to gas? By just heating it a little. Because even if you heat it a little, the intermolecular forces, the energy of those particles increase so much that the intermolecular forces of attraction are completely overcome directly. Because once you heat it even a little, the particle's energy increases so much that it completely overcomes the intermolecular forces of attraction and sublimes. Is this reasoning a part of your course? No. And again, when you cool it just a little, the intermolecular forces are strengthened so much that it skips the liquid state and directly becomes a solid. That's called de-sublimation. Easy peasy lemon squeezy? Yes, Arush, puche. Yes, guys. It does absolutely depend on the type of substance you're using, but you don't need to know the type of substance. I just give you two quick examples of carbon dioxide and of iodine. Iodine you need to know.
It's also important to note that deposition is the same thing as desublimation, and there's no such, you could use the word deposition and desublimation interchangeably, but you can't use the word solidification, because solidification actually stands for converting a liquid into a solid, right? So, or anything for that matter into a solid. So it does not cover the term gas to a solid without being first converted into a liquid. So you could use the word desublimation or deposition, not the word solidification. Okay.